hold the graph, this diagonal, flip it, and then you get this right here. Done. In this video, I'm going to help you understand how to shift the graph of a function and how to flip the graph of the function. And of course, we also have to study like what the equation will be. So this is how I would recommend you guys to take notes. For the shifting, we have four main directions, right? Up, down, left, right. Let's start with a parabola right in the middle, and the function is f of x is equal to x squared. Now, let's see what if I want to move this graph 2 times to the right. So right here, I want to get a graph that looks like this instead. So what do we do? Well, yes, this right here is positive 2, but you have to be super careful. Because if we go to the right 2 units, in fact, we take the function f of x, we will actually have to minus 2 for this. Why? Because originally the vertex is right here, right? 0, 0. So you have to end up with the y value 0. How can you end up with the y value 0 here? When x is 2, that's a positive 2, right? You will have to minus 2. 2 minus 2 gives you the 0. That's why when you shift to the right, you subtract 2 to the x. And the equation will be just plugging this into the original, so that's x minus 2 and then squared. Now on the other hand, if you want to go to the left, let's say 3 units, so let's say 1, 2, 3, we want to end up with negative 3 here. Well, in that case, what do we have to do? We actually have to add 3 directly to the x. So the equation here is f of x plus 3. Because the moment if you put the negative 3 into this x, negative 3 plus 3 will give you 0. And the equation for that is just x plus 3 to the second power. So remember, when you are doing like adding or subtracting directly to the x, you have to associate if it's left or right. If you're adding 3 directly to the x, you are moving the graph to the left, however many times. But if you're subtracting, you're moving the graph to the right, however many times. Now, how about up and down? Well, that's after the f of x. So let's say I want to go down. Let's say we want to go down just like 1, 2, 3, 4, 4 units right here. So the graph will look like this. Well, in that case, we will actually have to subtract 4 after the f of x. So the function here is f of x, and then just go ahead and minus 4. And the reason is because f of x represents the y value, right? And now, because the graph is going down 4 times, the entire y value will go down 4 by as well. So you do this minus 4. So the equation is this thing, which is x squared. And then after that, you have the minus 4. Like that. Now, if you are going up, let me just say go up 1 time like this. Here, this is the 1, and then I want to shift it up like this. You just add 1 after the f of x. So the equation is x squared plus 1, like that. Okay? But what if you want to go diagonally? Let's say I want to go diagonally, like this. So I will put down a picture like this. I want to go to the right 2 times, so 1, 2, and I also want to go up 1 time, so like this, and then the graph will look like this instead. Right here. Now how do we do it? Well, you just take this and that together, right? You're just putting 2 comments into that. So this graph is f, because we go to the right 2 times, I have to subtract 2 directly to the x. But this right here is going up by 1, so after the function, we will have to add 1 to it. And the equation is, put this into the original, so x minus 2 squared, and after that, we add a 1. So that will give you this parabola. And of course, you can also do the same thing for the other directions as well. So this is how you shift the graph of a function. Now, next, we are going to talk about how to flip the graph of a function. And in this case, I'm going to take the square root. And first, I'm just going to show you how to flip over the x-axis. So it's the upside down like this. So if you have it like this, the graph that we want to end up is going to be like this. It's upside down. And all we need to do is the following. Over the x-axis, originally we have positive y values, but now they become negative y values. So we just have to negate the function entirely. So we multiply negative by f of x. And we will end up with the equation negative square root of x. Flip it upside down, just like that. Now, what if I want to flip over the y-axis though? If you want to do it over the y-axis, it's a left and right. Yeah? Left, right, flip. It was on the right, now you'll be on the left. If it was on the left, you will be on the right. So, you have to associate that with the x. You have to do something directly to the x. If we take this, flip over to the other side, the picture will look like this. And we just have to negate the x value. So the equation for this is f of negative x. You multiply a negative directly to the x. And the equation is square root of negative x. But wait, we cannot have a negative inside of the square root, right? Well, don't worry. Because all these right here are negative x values, such as negative 4. If you put negative 4 right here into the x, you get square root of this negative, and then the x is negative 4. Altogether, you get positive inside of the square root. So this is square root of 4, and you get 2. So you will have that point right here. Negative 4, 2. So we are okay. Now, what if we want to do both flips? So in this case, again, we are just going to combine both of them, right? So what if I want to flip to the left and then flip upside down? Then in that case, the picture will look like this. All we are going to do is we're just going to do both. So the result is negative f of negative x, and that is negative square root of negative x, like that. And in fact, when you do this kind of flip like twice, it's actually a rotation from here, rotate 180 degrees. So what do I mean? Let me show you. This is the original graph, and then I'm just going to rotate it 180 degrees. And it doesn't matter if you do it like this, you get that picture, or if you do it like this, you also get that picture. It doesn't matter how you rotate 180 degrees, either clockwise or counterclockwise, just like that. Now, there's one more kind of flip that I'm going to show you. Okay, so for this one, the idea is that we are going to flip the graph over y is equal to x. And this is actually how we get the graph of the inverse function. So let's take a look at this one. And I'm just writing down as y is equal to square root of x, which is this graph here. So how do we flip that over y is equal to x though? Well, this is how I do it. You hold the diagonal right here, y is equal to x, this 45-degree diagonal, and then just really flip over, and then don't you see this part, the result of this part? That is the inverse. So the graph for it, it will be this part will be like this. So I'm going to write this down as when the x and y got switched, we have x is equal to square root of y, like that. And notice we still have to worry about the domain issue though, because this looks like a parabola, but it's actually just half of it, because we start with half of it. So just like that. Let me do it one more time. Hold the graph, this diagonal, flip it, and then you get this right here. Done. Now, next one, exponential function 2 to the x, which the graph looks like this, right? X-axis, y-axis, the graph looks like that. I want to get the inverse graph. We will flip the graph over y is equal to x. So you do this, like this, and then you flip over like that. Okay, so I have to do like this, right? And then flip over, and this portion is the result. So it will look like this. And this right here, x and y got switched. I will have x equals 2 to the y. And in fact, for this one right here, I can take the log on both sides. Y is equal to log base 2 of x. And this is how we have the log function as an inverse of the exponential. Just like that.